actually doing a lot of illusion type of thing. Give the illusion that a file is a 1 TB, but actually it's not. Give the illusion that we have 2 files, but actually they are pointing to the same file. This is the kernel part. The kernel gives you the illusion. But whether the underlying file system support this, it is the question. If the underlying file system doesn't support this, okay, let's say FAT32. FAT32 does not support a link. You cannot use LN. LN means link. You cannot create a link in FAT32. Then you cannot just do what I have experimented previously. Okay? So what is a file system underlying structure? We will go to this point now. Okay? It's about 2 things. The first thing is whether we can, dissect hard disk into some area so that we can save. I already give you 2 ideas, right? We have a directory structure, directory entries, and other is data chop. How can I allocate space? Chop it off in parts, okay, in a hard disk. This is question number 1. Question number 2 is after you chop it off, can you find it out? Okay? Then you can put something into a black hole, but you cannot get it back, right? Yeah. You can put something in a hard disk, but you may have a way to lose track of it. Okay? So the file system layout design is actually we call allocation and indexing. How you index the whole hard disk so that you can find your state as quickly as possible. Or allocation. How can you allocate this space so that you don't need to have a big old hand scan over the hard disk and find a space, put it there. Yeah, you can do it, but maybe it take 1 month. Yeah, if you don't scan it, in time you have what is the T now? 14, right? 50, 40, okay. 40 hard disks, buy 40 hard disks, you ask for space. You don't need to scan from the leading the first address to the ending address, right? So you have indexing part with the allocation part. All parts here are talking about speed. Okay? And speed is no longer about the algorithm in working on the memory. Okay? We have another a complexity, we call it the I/O complexity. How many I/O core we need, okay, in order to do it fast or do it slow. Okay? We have a introductory course on this, we call it what is the name? External data structure. Okay, this is a course okay, taught by Professor Tony Tao. Okay, he will talk about this external data structure, how to come up with an efficient algorithm on I/O, not on memory. Okay. So let's go with our prerequisites. Okay, our prerequisites is how many of you didn't buy a hard disk? Raise up your hand, don't be shy, okay? This question later on is become a default yes, okay? So I didn't buy it. How many of you have never bought a hard disk before?
External hard disk.
Yeah, never, any type of hard disk. Still good, okay? Last year we have half. How many buy a hard disk, okay? Next time maybe 5 years later, I'm still teaching this class, I have to bring a set of hard disks. This hard disk, A, this, B, C. Yeah, so if you have bought a hard disk, then you will understand what are the steps that you have to take before you really can put it in use, right? You have to open up your machines. Okay, I'll teach you this. This again is out of date thing. Okay, you never open up your case, right? You never open up your case, right? No, you never open it up. You never open up a platform, right? There's no way. Okay, or you do it more than me. Okay. So this is usually maybe next time I let you to open up my office computer. To come to my office and open it up for you. Okay? And when you open it up, you can find a very slots many for Dell. But the Dell design is good. Okay? It has slots to hold the hard disk. It has slots to route the wire. Very good. Okay. So you put it up, wire, put up data channel, put up power channel, and then put everything ready, power it on, then you will see this. What is this? How many of you have seen this before? Come on. Am I able to be faculty now? Yeah, I suppose that 3 or 4 guys, okay, it's not acceptable, okay? Yeah. BA faculty is more, okay? because they have more students. Okay, so this is a very important point here is when you insert a hard disk, okay, usually we're talking about there is an operating system inside so that you can boot it up, okay? And this is an illustration, a very high level illustration. Whenever you buy a hard disk, you have to give partition to it. Yeah, maybe this is the first time you heard about it, okay? And there's a partition. The partition, later on we'll talk about whether we should have a whole hard disk using a single partition, or a whole hard disk chopped into different partitions. Now, at this point, you don't know the answer, let me ask you whether you chop it off in a multiple partition or not. What is partition? Partition is a file system. You break it into several file systems. In the Windows term, you break it into C drive, D drive, D drive, F drive. Or you like one drive, C drive only. Okay? So who use one C drive only? Raise up your hand. Okay, you, okay. 3, 4, 5. Very few. How many of you break it into two? Don't tell me that it's because when you find it, it has C and D. Okay? Yeah, I know that, okay? When you find, oh, there's C and D, so I have 2, okay? How many of you have 2? And it's 2, okay? So, is it because the default has 2 drives? No, you do it by yourself. Okay, then what is the reason? Okay, so you think that this is a performance, right? How many of you is chop it off because of management? You want to put some files, let's say a game in one drive. Usually that is huge, 2 TB. Okay, a photo. So I don't know what that photo is. One drive. Everything, everything is not in drive. It's in the USB. Okay. Yeah. Is it? How many of you doing this? Yeah. So, fewer because you don't know how to control it, right? So, this is a typical layout, okay? We have a so-called primary partition, it's extended partition, okay? So, why there is a two thing? It's because of this area. We call it a master boot record. The master boot record is just containing 4 entries. That means that the amount of partitioning to create are only 4. Okay, only 4. And those 4 we call it primary partition, so that you can inside a primary partition you do some virtual control, which is not a real partition. Virtually give extended partition to it. Okay, so this is the layout, and well, usually you will, because of performance, there is a cascade of performance. There is most of you are doing the data management, put it somewhere. Some even because of outputting. Okay, so you dissect it different, so that you can use bootcamp or whatever things. You can put it up. I don't know whether some people will have this set up. Okay, don't use 7 is spec and it's not here. Always override the MPR. Okay. Yeah, usually we will do this with XP because it's smaller. Okay. Yeah, there's common reason, okay? And later on, we will explain why a smaller file system is more efficient. Okay? Really? Yeah. For me, okay, because I'm lazy now, okay, I just buy a computer and hold this to a single partition, okay? But usually when I do it, I hope that is an SSD, okay? I don't have a performance problem anymore if it's SSD, okay? So we'll take a look, and when we talk about FA32, why is that? And what is partition? I don't want to run the program anymore because you don't understand what it is. There is a program that is capable to read this MPR. Okay, if you want to run it, okay, I tell you how to do it. It's the same, first of all. Okay, I won't delete your MPR. Yeah, someone up because you know what is the consequence if I delete your MPR. Okay. Try it. Yeah, it's fun. Yeah, someone laughed at that. That one. That one. I don't have permission. Okay. I'm not administrator. I cannot change it. Maybe I put it out and try it. Okay, so this is the partition look. Okay, you will find that this is a management, the index management. how to index. What is an index? Index is just like at the end of your book, okay? There's a keyword. The keyword goes to where? The keyword goes to page 64 or page 65 and so forth. And this index is tell when you start a new partition, where you started, or where you ended, as well as what the partition type. Okay, it's all inside this Python thread. I know power. Okay, sorry. Where are power is later? It will tell you the specific data in this entry 16 bytes record. Okay, so you can run the program to access this record. Okay, so if you want to know how many partition type exist, you can visit this link. Okay, so it has decimal flag for partition type. So there are so many partition there. Something I never seen. What is that? Secure file system. I never seen this. 80 something is something that we know. Linux swap, any Windows. Windows anti-mirror set, what's that? Okay. NTFS, corrupted. Okay. Interesting, huh? There is a type for corruption. Okay. So this is a bunch of things here, but it's not oh, sorry, I pressed one button. It's not interesting, right? What's more interesting is about how we name or how we assess data. Okay. Now this figure seems to be a very old figure, right? Maybe in your primary school, secondary school, you've seen it. But today, we look at it from another angle. We look at this to relate performance with this figure. I will show you one movie, very good movie. And then we will end the class. Is it this movie? I have two because, yeah, let me see. Yeah. Okay, supposed to be this one. Let me make it full screen. So this guy is doing something dangerous. Open up a hard disk. Don't open it up. Never. Unless you want to damage the hard disk. Why? It's not because when you open it up, there's supposed to vacuum. No. Because when you open it up, some dust will land on it. Then that dust will damage the hard disk. Okay? So he is being a very brave guy. Okay? Okay, turn on the computer. Yeah, hear the sound. Wow, so many years I never hear sound before I switch to Mac. Okay, every day I hear the sound. Okay, now delete the folder. Very happy. This guy. Oh, I'm excited. Okay, it is deleting a folder. Yeah, wow, it's a big folder, huh? So still remember this sound? This sound is when your hard disk is so busy, then you can hear the sound, okay? It's actually because of this motor. This motor, when it's moving, it will produce a sound. Copy and paste. Copy, paste, yeah, for one to another one, another one, okay? Copy and paste. Just move we call it the head. The head is keep moving. Whenever the head is moving, you will produce sound. Okay, another one. Quick format. So do you know what is format? Maybe you don't know. Let me give you an idea first. Format means create file system. It's create a file system. Okay? So what is a long format and quick format? Quick format means that do the minimal job. Long format means that maybe it will scan whether the hard disk contains bad center or not. Okay, so this is doing the minimal job to wipe out the entire hard disk. Yeah, it is done. Done. So it is done. Okay, quick format. Power down. Okay, this is the end. Okay, so why I show you this movie? The movie is not about how funny it is moving. Okay. Yeah, I know it's funny to see this movie. Okay, but it's about the turning of the head. Okay? Actually, whenever you turn the head, it incurs times for it to turn and then stop and read the data. And the best hard disk can move this, okay, but the frequency per second is around 150 moves. Okay? So that means that whenever you access a plot, let's say a plot is 4K. Whenever 4K, you need to position this. You can calculate what is the speed or what is the bandwidth that hard disk will produce. It's extremely small, okay? Nowadays, the hard disk carry this is how many? It's now 6 GB, 6 gigabit, or 5, I can't remember. You know, 5 should be right. Anybody help me? I sell my hard disk anymore, okay? I just asked our system meeting, I want a hard disk. Okay, I want a hard disk. Okay? Yeah. Usually using SNTA, right? The bandwidth should be 6 GB, okay, per second. You can do a calculation. Whenever I move the head, I get 4K, and every second, the best type of hard disk is ranging from 180 to 130. What is the speed? What is data transfer? The rate. Very slow, okay? So for good file system design, we will minimize the turning of the head. And what is the meaning of reducing the number of turning of the head? Is to have sequential data access. Yeah, don't ask it to turn. Let it to spin, okay? When it spin, it will sequentially read something or write something. Okay? So just give you some idea, okay, here by using this movie and also the turn heading, something like that. Next time we will come back and